This is a typical problem. It is a common type of problem that comes in entrance exams. It says in a horizontal electric field E, so we have a horizontal electric field E, a pendulum bob is suspended. The bob has a charge of Q, value is given. So we all know it will not stay vertically, it will get shifted, say, to this position, making an angle theta with the vertical. Okay, so in this position, this is the string of the pendulum. We have to find the tension in this string. In a question like this, the first thing that should come to our mind is this bob is at equilibrium in this position because it is at rest at that point. So since this is at equilibrium, that means net force on this bob is 0, right? So the point to be noted here is net force on the bob is 0. Okay, now let's see what are the forces acting on this bob. One is the tension T of the string, one is mg, which will be vertically downward, its weight, and since this bob has some charge and it is in an electric field, it will experience a force in this direction along the electric field. So how much will this force be? Charged particle in an electric field, formula number 8. So that force will be equal to Q into E. Right? There are no other forces acting on this bob. These are the three forces. Now, the net force is equal to 0 implies that vector sum of these forces is 0. Now, in a situation like this, we usually do it in this way. Net force is 0 implies that net force along x-axis is 0 and net force along y-axis is also equal to 0. Let's consider the horizontal direction to be x-axis and the vertical direction to be y-axis. So this is along x-axis, this is along y-axis, but the tension T is inclined to the axis. So what we do is we resolve this T into a vertical component and into a horizontal component. So since this is theta, by geometry this is opposite angle, so this will be theta. This is T, this is theta, so this vertical component will be T cos theta and this horizontal component will be T sin theta. Okay, so this is the resolution of vectors, that concept. Now, net force along x-axis is 0, that means T sin theta it will be equal to this force, the force is equal to Q into E. Okay, force towards left is equal to force towards right. They will cancel each other out, so net force is 0. Similarly, net force along y-axis equal to 0. This will give us T cos theta vertically upward is equal to vertically downward force is mg. So these are the two equations we get here. And if I call it equation number 1, this is equation number 2. So in a situation like this, these are the common equations. You will always get these two equations. Now, decide what we have to find. In this question, we have to find T, the tension. So we have to eliminate theta. M, G, Q, E all are given. So in a situation like this, when we want to eliminate theta, the best way is square this, add it. What happens? See, if you square it on the left hand side, you get t square sine square theta. On this equation, it will become t square cos square theta. If you take t square common, it will be sine square theta plus cos square theta, which will become 1. So theta will get eliminated. And on this side, this will be q square u square plus m square g square. So you understood till this part? Now let's substitute the values and calculate. So from here, t square will be equal to q square, that is 4 into 10 to the power minus 16 into e square, that is 4 into 10 to the power 1, 2, 3, 4. So that will be 8 plus m square, so 30.7 square into 10 to the power minus 12 into g square 9.8 square. So this will be 9.8 square. Now if you do the calculations, T will come out to be 5 into 10 to the power minus 4 Newton, which is option C. Clear?